My name is Akra, and I'm here with Kamal and Tony right in the front row to talk about how we use a OSGi-based platform to build like an extensible platform. And why extensible? I think we'll spend a good amount of time talking about this adaptable, scalable, extensible platform for the organization, how it solves our problems, right? So let me just jump right in and go to the agenda. So I think the first part I'll talk about is why we do this, what are the philosophies behind it, what are the problems we are trying to solve, and then Kamal will take you into the platform itself, how Raptor is done, what kind of assumptions we made with this platform. Okay, of course, an organization like eBay that has to release software frequently, very frequently actually. Once every week, less than once every week for many cases. The PDLC is a very important piece. So Tony will talk about the PDLC, how we make that work, okay? And I'll come back and talk about the rest. Some logistics here. I mean, I try to go through this a little fast, and it's a lot of high-level information. Feel free to ask, but please let us finish the slides, and I'll try to leave as much time as possible for any questions. And if you still have further questions, you can catch me outside as well, okay? So jump right into the problem. Okay, so what is eBay? I don't have to tell you what the site is. Let me see. No, it's this connector here that's going wrong, okay? So very clearly, I hope everybody knows eBay. We are an e-commerce site, okay? And the content that we serve is all dynamic. So you do something, you put in the URL twice, you get different results, right? You search for the same item 2 times, you will see new bidders coming in, new sellers coming in for that same item, and some other bids expiring or some items sold, right? So it's all very dynamic. The consumers or the users of our system is usually web browsers and mobile devices, but that doesn't preclude things like Google bots that occasionally jump in and crawl our site. So we have to deal with all that. Scaling is massive. We are talking about thousands. I'm not sure. We are probably at the edge of thousands or tens of thousands of servers at this point. Okay, billions of hits per day. Even a single application has got a huge number of hits. Okay, and each of these hits are small. We have to respond to you within a couple of milliseconds, okay? Because the internet takes your time. If you respond in 200 milliseconds, it will probably be like a second or 2 seconds until you see it on your browser, okay? So performance latency is very, very critical. And all our systems for flexibility of allocation and reallocation, they are all virtualized. eBay as a site, from the application standpoint, we are talking about hundreds of applications. You go into eBay, you go to the homepage, you go search for something, you view that item, you go bid for that item, okay? Or you want to sell something. These are all actually different applications done by different teams. So how do we pull that together and make eBay move as a site while we do not stop eBay if we want to change something is the challenge that we are trying to solve here. So agility, we roll out code all the time. If you have to wait for 2 weeks, 4 weeks, or a release cycle of 6 weeks to roll out code, eBay would be obsolete by then. So code goes out all the time, right? Based on that, people cannot work with systems that are really in their way. How do we build systems that are not in their way? I think that's the key issue, okay? The systems should always help people and not create more friction for people, for developers to use. So if your developers come in, or our developers come in and say, I want technology XYZ, we have to think about how can we make that happen, okay? Because probably that technology is what solves their problem. So we cannot say, okay, we have got this thing, whatever it's called, and you have to use that for your problem, no matter how hard it is. This is what you get. That's no longer the case, right? From the complexity standpoint, we are talking about 40, 50 million lines of code, roughly. And also, we hire people, hire developers all the time. If you need to spend 3 months training developers to be productive in eBay, we have lost a lot of their time already. So the concept is you have to be productive. Coming to eBay, you have to be productive on the first day, which means the technology has to be familiar. You can look at it outside, okay? You can apply your knowledge that you have learned outside in eBay and vice versa. Whatever you learn in eBay, you can go out and apply it outside as well, right? Instead of maintaining a huge stack of documentation, you should rather be able to Google for your answer, right? Everything should be on the internet, besides a couple of things that deal with how we operate as a site. Disruption is not really easy to deal with, right? We cannot say, okay, our system is old, let's stop eBay and rebuild the system. Or let not work on the old system for a year, 2 years, and build a new system. That's a lot of what enterprises do. Basically, they have got their ERP system coming in, and they use it for 5 years, 10 years, and then they say, okay, this thing is no longer workable. So they go hire somebody very expensive and build a new thing in there, or purchase and customize, right? So when you make these kind of changes, if they are very disruptive, you have to change the whole org because people are used to what they were working on. You cannot just go and say, tomorrow the way you work is going to be different. That doesn't work, right? So that's why we say, okay, since we have got so many different units of work, units of development team, each team can choose what they want to use. And they can choose based on, we have to have a portfolio. We probably cannot, from a support standpoint, support all the technologies, but also try to make it very easy for people to say, I have got this kind of problem, and this is the framework that solves my problem the best. And yes, you should be able to do that, okay? So unfortunately, these changes that we are trying to do, or that people try to do, and non-disruption is not compatible, and we are trying to make it work. Philosophies real quick. So anybody in the Java world knows about things like JAX-RX, JAX-WS for web services, Spring, okay, Java EE. I didn't list it because Java EE is also a big umbrella of so many frameworks. Players coming in. We have got Scala-based frameworks, JavaScript-based frameworks, and you can name it. There's plenty of those. The problem is, if I give you a framework and I say, you live with it, right? What is your reaction? So first of all, you might say, okay, we'll live with it. And then when it doesn't quite work for you, you'll start complaining. If you need so much code to make it work for you, you'll complain more. And at the end, you'll say, no, forget it, okay? So there are teams that are like that too in the past. So we try to make things easy for the teams. We don't want people to run into frameworkitis, and you can read the definition out here by yourself. Frameworks. Am I on 2 mics here? No. So each framework is designed for a certain use case, right? You use most MVC frameworks that fit very well with certain kind of pages. If you need a lot of interaction, you might want to go for frameworks like JSF, okay? There are also, let's say you want to work on mobile, there might be certain JavaScript frameworks that are good for you, certain other things might be in your way. So we don't want to define which framework is good for you. We want to make sure that everything is working for you. That's really the key message here. How do we choose? No, we don't choose, right? We choose the minimum, and we say, what's the right choice for you, okay? If we say, go for A, B, C, whatever it is, by the time we decide that framework is obsolete. So IT shops tend to do that. We did that mistake in the past as well. We say, this is our grandiose framework that does everything. And then soon after that, this grandiose framework is obsolete. Okay, and now you have to spend all the works building yet another grandiose framework. Okay, so we don't want to build our own. If we need to revamp that, that's going to be very costly, right? I just want to put this quote out. Bill Joy, Agile 1, I don't remember the year, probably in the mid-2000s, said that innovation happens elsewhere. So no matter what we do, no matter we put the best engineers out there will always be better ideas somewhere else. So putting the whole knowledge into one engineering team is like putting all your eggs in one basket. And if that breaks, you know what's happening, right? So instead, we decided to deal with open source, try to integrate open source technologies and allow for integration of open source technologies, right? And if there's new open source technologies coming in, we can integrate those. Okay. Surface area, when we say minimal surface area, meaning that eBay APIs should be minimal. You should be able to learn that in a very short amount of time. Okay. And of course, we need to think about how we roll, how we allow people to develop now and get things onto the site by the end of the day. That is when we define agility. That includes all the dev cycle, test, QE cycle, quality cycle, okay, to getting out on site. So with that, that's kind of good lead into Raptor, which is the solution that we have come up with. Raptor is more like a meta platform, and I'll get Kamal to talk about Raptor in more detail. All right, come on.
Hi everyone. So I'll get into the details of Raptor. So to summarize what Akara was pointing out is like, instead of a framework being a constrained environment where it makes you to work within that constraint, a Raptor is more of a framework which allows you to be, it's like an enabler which enables to build on top of it. So that's a key philosophy here. Instead of constraining yourself, we become the more like an enabler which enables you to do more. So to go with that, again, we cannot, there's no one framework which can satisfy everything, but we try to put effort that we can suffice as much as possible. So the minimum assumptions what we took here is, we took some criteria. The one of the criteria was for our code where we had millions of lines of code in a monolithic code base. The first thing was to make it more modular. So when you talk about modularity, the first thing comes into mind is OSGi. So that's the first thing which we brought up. So we went and adapted OSGi. And on top of which, we adapted J2E, basically for all the web applications and servlet APIs for doing web-based applications. And then we thought about making our apps more loosely coupled within our code and things like that. So dependency injection is needed. And obviously, Spring was a choice. And also one more thing is Spring not only comes with dependency, there's a lot of suite of things available in Spring, like you have AOP and things like that. So we thought it will be a good suit for people who want to develop on top of it. So being this is what is basic the assumptions. So what it allows you to do is it allows you to build any JVM-based dynamic languages on top of it. At this point, you can have choices like you can bring Scala, Extend, or any Spring-based application, Grails on top of this platform, and you can build it as long as they constrain to some of the minimum things, like it should be an OSGi bundle, as long as it works within that environment. So as I told, Raptor platform itself is more modular. It is divided into multiple smaller units. The first thing is, like in Raptor, is called as a Raptor kernel, which is a core which is built on top of OSGi itself. So one philosophy what we wanted to adapt is we want to prevent application developers to getting into OSGi APIs. So we want the code to be more at a top level as an application level, instead of they getting into OSGi APIs and exploring into all the OSGi things. So we act as a layer of abstraction and we control a lot of things. So Raptor kernel is a layer which interacts with all the underlying systems. like interacting with OSGi's, like we use a extender pattern where we talk to bundle listeners, bundle trackers. So this is like a core layer which on top of which all applications are built. So some of the key features of Raptor kernel is we use the OSGi extender model. So we use bundle tracker to track the lifecycle events of the bundles. So whenever the bundle comes in and goes, we use some mechanisms to track these bundle events and make some decisions based on that. So we are going to see what all in what all areas we are using this and how we benefit from that. Some other things which is part of core is initialization. Any app which has to be running needs something during the initialization. So how do each of the applications which contributes bundle can define their own initialization, and how do we make sure that all this initial happens in the right order to make sure that everything comes up and ready for serving the first request. So it reduces your first request time if you do your caching and everything during the initialization. Lifecycle management, again, it's about how do you manage the bundles, how it comes up, how it goes down. How do you know that if an app may be consisting of 10 bundles, how do we make sure that an app is up and running only when after all 10 bundles are available? That means you need to have a knowledge of what has to be initialized, what is up and done. So that's a lifecycle management. So operation support infrastructure is like once you deploy your app, how operation is going to monitor this app. In what all ways we can provide data, whether the app is running successfully or is there any exceptions. How do we communicate it back? So Raptor kernel provides a way of exposing all this data to the operations for doing any kind of validation and things like that. Pipeline and handler, it's similar to an interceptor concept where you want a request and you want a request to be going through a kind of a pipeline where you have multiple channels and your bundle may want to do something. For example, a simple thing is you want to get your response gzip for compression. So this could be one handler in a pipeline. So we have a mechanism where you can inject your handlers for any request or response and we can process on the data. So I'll talk about that. And OSGi, we use OSGi to figuring out when the bundle comes up and when this should be used and things like that. So case for OSGi. So a lot of people ask why OSGi. So as Akara was pointing out, when you talk about a company, enterprise company, the first thing you will see is a monolithic code base. Like the reason is very simple, because people want integrity. Like if you give it to different people, if you divide a code base into different modules, it requires discipline. You need to know how to give your dependencies, how to version things. So there's a lot of challenges which comes in with it, but as well as you have benefits. So when you talk about any code base which is monolithic, which is one single big bunch, it's always a problem. So we wanted to go in a route which is very modular, easier to deploy applications independently and scale them independently instead of creating one big chunk of code. So OSGi is one solution which gives you the modularity aspect of it. Modularity is one aspect of OSGi. There's a lot many to that. So one thing is like, I can give a simple example. There are a lot of use cases. One simple example is, let's say that we had a functionality in the kernel. Kernel is mostly interacts with the JVM. So we had an implementation and which is not supposed to be exposed to the applications team. But since we were in a non-OSGi world, there's no way to control that. So what happened is people were using that implementation somewhere in the code. And once we changed the kernel implementation, every app broke. The reason is very simple, because we were not able to encapsulate it and abstract it in a way that people don't use it because it was an implementation detail. So these are things which were very clear, like unclear APIs. There's no defined boundaries and backward incompatibility problem. So because of this, you need to keep on maintaining the backward incompatibility because people are not going to, breaking 100 apps, not 100 apps is going to fix it. So you are going to go back and do something to make it work. So these are things which gave away, and we thought that OSGi is a solution to move towards. And how OSGi solves the problem? So it gives you a bundle lifetime, dynamic nature, runtime nature, where you can bring in bundles and take out bundles during the runtime. It gives you a dependency which is very valid during the runtime. That means when two bundles comes up, each bundle should know what it depends on and also what it can expose. So that capability is not available in the normal J2E world, where any bundle can define, hey, I have around 10 packages. What I'm going to say is I'm going to only expose the interface packages and not the implementation details. So what this allows is, as a platform team, you can always go back and change the implementation at your will instead of breaking any app, because the interfaces are same. You can change your algorithms, you can change something, you can improve performance without breaking anybody. because nobody can access that piece of code, so it is not used by others. And then finally, as I said, it requires some discipline, and that's where semantic versioning comes into play. If you use semantic versioning properly, actually we can solve a lot of issues which is related to backward incompatibility, the way code gets dependencies are like wired, things like that. So this is the granularity of modularity. Basically, you can see that how all you can modularize your code. If you talk about in a very general architecture level, people talk about separating your services and your UI. It's basically front end and a back end. So that's where your service modularization comes into play. And then if you break an application itself, it consists of multiple modules. So in J2E terms, you call it as jars. Jars are not actually modules, but still they act as a boundary for the current code. In the OSGi world, we have a called as bundles because it provides you another better mechanism where you have other levels of granularity like packages. A bundle can consist of multiple packages, and each package can have multiple classes. A class is a more granular level. That's why OSGi choose a little bit higher level, which is packages. So you can control your modularity at the packages level. So whenever you define a bundle, as an owner of the bundle, you are going to say, hey, I have 5 packages. Should I'm going to expose all the 5? Or no, I'm having 3 implementation. I don't want to expose all the 5. I'm going to only expose the interfaces which are in the 2 packages, and implementation is going to be hidden. So you have a control as a bundle owner to say, hey, what is going to be exposed and what is not going to be exposed. And similarly, you need to define your dependencies. I'm going to say, hey, I need these packages for my execution. So it defines a very clear level of dependency thing which is not available in the current system. So these are like some features what you get by going into modularity. So currently, Raptor as a platform, on top of this minimal assumption, we provide some capabilities. So a couple of them are like we support Spring MVC for developing web apps, which is basically the view is a JSP. We also support JSF with limited capabilities. And then we have a JaxRS, which is a Jersey. We have a wrapper over Jersey, which provides our infrastructure things along with it. Future, as I said, we want to be the enablers so that as long as the platform is evolving and it always provides a way for people to bring in new technologies, it's always a possibility we can go to other things. For example, we have already prototyped scalars, extend, and things like that. So there's nothing which stops you from going on top of it. So that is a key thing which you want to bring as a key feature of Raptor. So these are going into details of what Raptor. I talked about a pipeline. So what is a pipeline is all about? So there are a lot of things which you don't want application developers to deal with. For example, aspects, right? Normally you have something like security, logging, things like that, which you don't want the application developer to get into for each and every service he writes or every web application, right? So how do we manage these things? So whenever a request comes in, how do we make sure that the security level is there for this particular request to access this, the authorization part of it? How do you make sure that this request gets logged? What all is the payload of this thing? So these things can be achieved by using this methodology called pipeline. It's a very interceptor pattern like your filters, but it has more flexibility where bundles can say that, hey, I need these handlers. So as a platform team, we have a set of handlers. Like as a eBay, as a company, we need some infrastructure, some things which needs to be by default, like authentication, authorization, logging, all security aspects. But other than that, there could be n number of things what application teams may want to add. So they can have their own handlers. So which means that whenever a request comes in, it goes through this pipeline, and every handler in that particular pipeline will be executed before the request goes to the actual application. So in this way, we have a more easier way to control things, or if you want to do any processing, like we can improve the performance by doing a gzip on the response. So the payload gets reserved on the response. So things like that. And we use MVC on the backend, and also we use something like cross-context app. So your app itself runs in a different context, and we communicate through cross-context. So infrastructure on demand. This is nothing but how we use OSGi's extender pattern. So we use bundle tracker, which is a way to asynchronously monitor all the lifecycle events of the bundle. So we have a mechanism in the kernel where it tracks every bundle, and we figure out that for this particular bundle, we look into the manifest, and if there are any special headers, we do some special parsing. Like for example, initialization. If a bundle wants to do initialization, they will write an initializer, and they will provide a header, which will basically the kernel understands, and take into consideration. And we also have priorities and things like that on that. But the mechanism what we are talking about is always extensible. So you can use it for anything. We use it for identifying bundles which is exposing resources. We use it for a lot of purposes, but the pattern is same, but the purpose could be different. So some of the examples are what modules are getting initialized, what all, whether an app, for example, you may have 10 bundles for your app, which may depend on 100 things. But how do you make sure that your app is up and running only after 10 of them are initialized? So all these things can be controlled by this. So some of the infrastructure thing is data accessing. So you need a layer for that. Security, logging, tracking, experimentation. It's like identifying how many clicks happen. All these things can be done using this thing. For example, tracking is a mechanism to say, like, for example, in this page, how many people access this page. So you get the data. It's by like metrics. All these things are possible, and it is all part of the platform. It is enabled by default, so apps need not do anything on top of it. So they can just control the behaviors, but it comes as a capability. So eBay is a service. Already we are in a service-based strategy. But with Raptor, one of the main philosophy is that we wanted to separate all web applications from accessing the database. So we want to have a clear separation where services are going to be the, so we want everything to be a service, and all the data access, all things should be moved to the service, and web application should perform what it should perform. So this was a strategy which we adopted long back, but with Raptor, we are enabling it a lot more, and also we are pushing people to go into this architecture so that whenever they develop an application, they don't have to do all this data access and everything in the web application. It should be a service. So that is a key idea about it. So this was one way of modularizing your whole code. And as Akara was pointing out, eBay consists of hundreds of apps. If you go to eBay homepage, it's actually actually a pool of missions which is serving the request. If you click on an item, what you see as a view item is another pool of servers which is actually serving that request. So everything what you see in eBay are loosely coupled applications which are independently running on their own pools, which means that people can roll out code and scale in accordingly instead of waiting for somebody else to roll in and things. So it's not one single code base running on one set of missions. It's a different applications running in an isolated manner and communicating through links and services. So it means that in this case, what happens is if there is a web application like view item, and if that view item is like, it's a page where you see the item in eBay, they can evolve on their own independently without depending on any other thing, as long as the platform provides all the capabilities for the evolution. So this is the architectural layering of how eBay is. So we have an infrastructure layer which takes care of all the infrastructure like your cloud for deployment, and we have data sensors, computes, basically network, all the infrastructure pieces. And on top of which, we have a technology platform. So this is where you have all your key pieces like your data access layer, your SOAS framework, your presentation framework, messaging framework, logging framework, all the infrastructure technologies which is needed for any application to build. And on top of which, we have services. So this is what I was talking about, the service strategy. So everything should be available as a service. So when an app comes in, it's about orchestrating the services together and bringing up a vertical experience or any particular app which you want to develop. So applications builds on services. So as a technology platform, what we do is we enable people to develop applications faster. And also as a services-oriented company, if you have everything as a service, the application is like a thin layer which just orchestrates everything together and gets an app as soon as possible. So it allows you to do a faster PDLC, prototyping, or do an experimentation in a faster manner rather than if you are going to do it from scratch up, it's very difficult. So the basic, as I told in the first, we want to be the enablers. So we are not restricting people saying that, hey, if we are choosing to our framework, you can use only ABC. As long as it adheres to Java-based, any dynamic language, as long as it is an OSGi-based thing, we can always choose your own framework and from a supported list, basically, because I cannot say, hey, you can go and run Node.js on this, or as long as it is supported, yes. But if it's entirely a different platform, we need another mechanism to accommodate it, not with what we have, the current capability. So new apps always so what the way we are going forward, as Sakara was pointing, we cannot go for a disruptive change where we can say that, hey, we are going to stop eBay today, totally whatever is there, and we are going to build on it. It's not possible, because it's a huge effort if you're going to do that. So we need to do it in phases. So we need to start with moving some apps first. Let's say that if there's an application which has both the codes together, we need to separate out the web app first, and then we start slowly migrating them, creating services, and building on top of it. So the idea is that any new app comes in, we'll be always starting in the new environment, and the old app still resides on the other one, and we slowly migrate them to them as we have more services and environments coming on. So it's a mixed environment where we have applications running on the older framework, which is a monolithic code, and we have applications which is running on the new one, which is a Raptor, which is basically a very modular application. With this, I hand it over to Tony to talk about the PDLC thing.
Okay. So I think Kamal and Kara has talked to you a lot more on the technology side, sort of the platform, right? What frameworks and how we support it in a very agile way. Now, I think the other part that we actually spend, I would argue, equal amount of energy and efforts is really how we kind of redo our application lifecycle, or PDLC, right? Taking our developers from just developing the code and all the way to how that application get rolled in production, right? And in order really to have a really fast turnaround for us, right, we really need to optimize that whole life cycle, right? So that, the goal that we really have is that, we have some new hire coming in, maybe they make a small change in our app, and how they can go from there in the Eclipse IDE to production, right, within an hour, right? So there's a lot of work that we have done in this area. So this diagram kind of shows you some of the main stages that we have looked at throughout the whole PDLC, right? So the developer part, kind of Kamel has talked to you a lot about it, right? What technology, what frameworks we have. We have a lot of tooling around that as well to help the developers be productive, right? On the version control, we have actually make a switch, right, on in terms of what SCM we are using. So we are using Git as well as GitHub in a way. Which we felt, eBay, has a lot of distributed teams actually, and we felt that, we used to be using a much more centralized type of source code development kind of product, and we felt Git is much more suited for kind of more distributed development, and we got a lot of performance benefits out of that as well. And that's also sort of the social aspect, I think, that we got from GitHub as well, which we are in a way still experimenting, but we kind of see that could be some benefits to sort of a large organization like eBay in terms of how to share and be aware of what other teams are doing. Okay, the register step here is really all about because in eBay, right, all your application in the end has to go on to some front end facing, right, edge, right, something that can be accessed by our end user, right? So in our company, right, what happens is when you build a new app, right, okay, you need to now host it somewhere. Then you kind of have to submit some tickets, right? Some IT ops group is going to take their time to build a cluster for you and all this stuff, right? So we don't want that at all, right? Because as you notice, right, we have hundreds of applications from different groups, right? If every time we need to do a new app, we have to go through that multi-week kind of cycle, that just doesn't work, right, to try to get to production in 1 hour. So we have this step, which is a self-service step, and essentially you register your application, you provide some metadata, like which team you are, what kind of app it is, and we basically have our machinery automation to essentially kickstart the creation of the pool, and I'll talk a little bit about that environment. That's sort of our cloud environment that we have developed at eBay to enable that. Okay. We are heavy user, just like I think many companies, right, of CI. We use Jenkins, Hudson, so do builds. There's a lot of stuff that we do with that, and we try to automate a lot of that. The assembly step is really more about taking all the artifacts that we really need and package it in a way so that the same artifact can be used to deploy in different environments, in QA environment, development environment, production environment, and kind of provide that isolation so that we know that that's sort of like a golden kind of copy so that if there's some changes in development or whatever, that's not going to affect that copy unless we explicitly kind of regenerate that golden image. And then last step is sort of the deployment step that I will talk about later. So from a kind of assembly point of view, I guess, so we definitely use CI to do that, right? So to us, CI gives us a lot of advantage. One is really, the biggest part is really the consistency part, so before sometimes, right, what might happen is sometimes the developers, right, would build some library on their box and then somehow they would check it into some repo and eventually that would make it out to production, right? But that, you kind of lose that consistency right there, right? Because it's built using the development environment and maybe you might actually have trouble rebuilding that artifact later on, right? When there's some issue that you need to fix, right? So essentially, we enforce the fact that all the artifacts that goes out to QA or production environment has to go through the CI, right? There's really no other way. And also the CI also do more than just build, right? We'll run all kinds of tests on the artifacts, as well as some of the static analysis, right? Like find bugs, we have unit test coverage, all those stuff, right? So all those are built into the different pipelines, in our CI. And we also, I think, inject, and I'll talk about it a bit later, that, before the code would go out to production, we also insert a human step, which is our QA, essentially, has to sort of officially blast a particular version. And those would be the only version that you can select to roll out to production. In terms of actual artifacts that we deploy, we have so we are OSGi based, right? So our application consists of typically a number of OSGi bundles, right? And then at the top level, right, we basically have this enterprise bundle archive, EBA, which essentially describes the top level bundles that are used by the particular application, okay? And the other important part is what we have, which is a configuration files. And the key here is really that we have built in our configuration mechanism so that we can distinguish different environments so that we don't have to rebuild our app just to deploy to a QA environment versus a production environment. Because sometimes your configuration might have to change, right? When you're in this different environment, you have different host name, maybe your capacity is different, maybe you want to react differently. But because we build that in the environment support into our configuration mechanism, so you don't need to rebuild anything, right? Because you can inherit, like maybe your production environment can inherit from the QA environment, or you can override some of those things. Okay. And then the last step is really to generate, take all these artifacts and create this golden image. And as I mentioned, all this step can only happen if we pass all the tests that we deem necessary, as well as having the QA certification. So this picture really just sort of explain a little bit on the OSGi bundle creation that we have. So we have kind of taken the approach where we, as you have heard, we actually try to minimize the exposure of OSGi a little bit from our end developers. So we kind of taken an approach where our developer is very familiar with Maven and Palm, so we are sort of taking that approach where we are generating the OSGi manifest actually from the Palm definition, right, with sort of the Palm plugin, right? So for the most part, the developers still need to have some knowledge of OSGi, but for the most part, they are almost kind of assembling their application through Palm dependencies, okay? And then through those Palm dependencies, we will generate the corresponding OSGi manifest, right? And then we would actually store those bundles into our Maven repository, right? So we are not directly using kind of the OSGi bundle repository, etc. Right? We are still in a way relying on Maven as a repository for our bundles. Okay, now in terms of how and this part is sort of the deployment part, right? How we can enable our individual teams, right? When they have a new idea, they want to create an app. How can we get them to production as quick as possible, right? So we have actually invested, in sort of building multi-tenant private cloud type of infrastructure in a way. I think that the key here is that we really want to make this to be self-service. Okay, so the development team actually, does not need to, in a way, try to submit some tickets and wait for multiple weeks in order to get their cluster, right? They just go to a self-service portal. They can put in a few parameters on, how big their cluster needs to be, which data center they want, and we have done our work to kind of automate sort of the workflow that is needed to provision this type of pool. We will actually form the cluster automatically for them as well. So we would configure our load balancers so that all the machines will be put behind the LB and then can actually serve traffic. All right. And we really just, in a way, try to make it just like, a lot of companies using this, external cloud type of service. We want to provide the same kind of frictionless environment within eBay. Okay. In terms of scale, we are actually leveraging the cloud to provision over tens of thousands of VMs today, and serving hundreds of applications. So it's a pretty large scale. And we feel that this internal cloud really have given us both the agility, right, in terms of from an idea to production, they can get their pool done within an hour, as well as the efficiency by kind of centralizing a lot of these resources and virtualizing them. We felt it's better efficiency than every team just try to get their own boxes, right, and try to configure them, right. In the future, we're also looking at how we can do some of the scaling part as well, right? So today, the scaling is still done, like you would need to request, right? When you feel like your application is reaching the capacity, you can go through this self-service portal and say, okay, I need to add a few more nodes to my cluster. But we're also looking at how can we actually even do that automatically, right? By looking at the traffic and be able to also remediate our machines, right? When something goes wrong, how can we take out that node and replace it with something so that it can continue to function. Okay. So that's sort of the infrastructure part, right? So you get your compute, right? But I think for developers, that's only part of the equation, right? The next part is sort of how we can help them to get their code to this big cluster of machines, right? In a very seamless way, right? So again, we are following a self-service path here, right? So there's no like a central release team per se that developers has to tell them, oh, roll out some stuff to production, right? So we are in a way empowering our development team, right? So individual development team can decide when they want to roll out their particular applications. And as long as the CI pipeline is all green, they can actually roll out their new version, right, to the production, right? Again, through a self-service type of machinery. But in order to do that, we actually have to build in a lot of intelligence, right, into our deployment mechanism, right? For example, right, it is not acceptable for eBay to roll out some new version of the code. You take down that part of the site, right, under maintenance, and then you update the code, etc. Right? So we actually build in things like rolling upgrade automatically. So our deployment knows how to take boxes out of the rotation from the load balancer, right, and do it only a small chunk at a time, right, so that you don't impact the overall capacity for the site, right, and then you roll out the code and then you put it back to the load balancer. So all this is sort of handled automatically, right. The developer doesn't need to worry about doing this one step at a time. We also have what we call different kind of rollout strategy. So a lot of times what happens is it's sort of maybe some kind of big change in our code. So we don't want to just roll out to the whole production site, right? What if there's some issues, right? So we have ability to, let's roll out to just a couple of boxes and then pause right there and just let this sort of run and bake maybe, over a couple of days, and we observe the log and monitoring to see if everything is good, right? Before we resume sort of the overall rollout, right? To that, right? So there's different kind of things that we do, or we can do A/B kind of rollout. So we direct half of the traffic to this new version and maybe some to the old one and see how that performs. Okay. The other important features we have is sort of the fast rollback, right? So sometimes if in the end there's some issue with the new code, we can actually roll back very quickly by having the older version on the boxes as well. So we just sort of flip the pointer in a way to the code base so that we can have a very fast rollback. Okay. And in the end, I think what we truly enforce, right, with this mechanism is that we have that consistency of the code, versus the manual way where sometimes, when you have a really big cluster, there's a lot of time what happens is you might actually end up slightly different versions of code on different clusters if you're not careful. But with this automation, I think we pretty much ensure that we have this eventual consistency of the code version, even if your cluster is like several hundreds nodes across different data centers. Okay. And this picture, in a way, is just a sort of a summary of what I kind of mentioned, right? So on the left is sort of the packaging golden image units that we have, right? So we talk about, the top part, we have the applications, right? We have the OSGi bundles, the EBA, etc. We have the configuration files, and then we also have the container as well as the Java virtual machine as well, right? We really want to create this isolated golden image so that it's not going to be affected by the development activity. So we can repeat, we have that repeatability so that we know when we deploy this deployment unit, it will be the one that we have blessed. And as I mentioned, we can go to different environments, the same piece of code go to different environments across different data center. And we have that whole rolling upgrade type of management for our deployment. And then with that, I'm going to hand it back to Akira for summarize.
So, summarizing, I'll give you some look backs here. We started this project on the most complicated application, and that I think was a big plus. And basically tackling the beast, the most difficult case first, right? Only focus on that use case. And we actually resolved all the issues in a reasonable amount of time because it is a big success as they went live. Now Raptor is serving 100% of that traffic on eBay at this point in time. Okay, I think one of the things that causes us to go through a lot of headaches is the principles part. Okay, basically, when we came up with new ideas, we don't say, oh, it has been done like this in the past. We say, no, that's not right. This is the way it should happen. And we focus on solving all these issues, including all the process issues. Okay. On the other hand, the code, because the old eBay code was also Java-based, you can kind of refactor the code, in some cases copy or even repackage the code in some cases to make use of what we had before, right? While we are adopting the new technology, while the front end is changing a lot, some of the core business logic has been taken from the old code. That was kind of beneficial. Challenges. Tooling is the biggest challenge in OSGi, okay? Because OSGi is, well, it has been around for some time, but it is also fairly new. So how do we build, how do we package all that Kamal and Tony has been talking about? The runtime is probably the easiest part, but the tooling part to make it work together and know how to resolve issues, you get some users exceptions, users errors. Container doesn't want to come up. How do you deal with that? Those are the biggest challenges, right? OSGi also creates certain constraints. You cannot just go and load classes dynamically from somewhere you don't know. Okay, so we have to prepare for that. That was one of the other challenges. Okay, the project was involving not only the container, but also the whole PDLC, the whole build system, the whole packaging system. So all of those were very complex systems, and I'm really, really glad that we got here in the way we are and solved most of those issues, if not all of those issues, by now. Okay, service is another big issue. Once we went to production with this new service-oriented architecture, you think that services are like method calls, like you go to a service and it just responds. Well, the network is unreliable. So you have to say that services are unreliable too. And not too many application developers know how to write code to deal with services. So we are still facing that challenge at this point, and we have our roadmap how to solve that. But I think that's the biggest learning curve that we went through as well, is how to deal with services and how to solve that in a way that application developers don't have to come back and say, how do I write code to deal with this, right? And the source base, it was a monolith before Raptor. So we start to untangle, but not everything is untangled yet, right? The developers tend to not think much about modularity. They say, oh, I need this code from that place. They just go and grab that code. They don't think about, is that the right place to grab? In the recent cases, they went to another application and say, I'm pulling in that code, that bundle from another application. They don't know that that bundle has got 100 more dependencies. Okay, so training that and dealing with it is going to be a challenge. We are talking about many hundreds of bundles in this case, right? Still, I still consider this project to take us the way we want to go. And we have to accelerate movement of the old code to the modular code. Raptor started on the front end, so one of the customer-facing apps took the traffic first. But also we are moving Raptor to the service layer in the back end, right? Where basically we talk mostly for Raptor will be REST services to the back end, okay? We need better instrumentation, better tracing. So when a request comes in and goes through, makes a service call, that service call makes another service call, and finally it arrives at some persistent data store, right? How do you trace these calls from one environment to the other environment? Say that, oh, the time, the call took too long. So the time was spent at this layer, at this place, right? We need to build all that coupling, the tracing layer together. So that is still work in progress. We have got a lot done where we can say we can identify the bottlenecks at this point, but we cannot dynamically change these. So that's really the next step with the instrumentation part, okay? And that's pretty much it. Let me just try to go to the summary. So certainly, I think we made this happen. We made OSGi happen with all the odds that came against it. But I think eBay as a whole benefited from that. And I hope that a lot of people who are going this path also would benefit. It's a pain before you start to see the benefits, but I hope you will see the benefits, okay? So from the OSGi, from services, from cloud, okay? And I think PDLC, we had to revamp the whole PDLC. In the past, it was rolled out as pretty much one chunk to the whole of eBay. So you would know how that release management looked like, okay? Just think about that, right? So what do we get as a result of this is our ability to move forward, to adopt new frameworks. And actually, Kamal alluded a little bit about Java-based or JVM-based frameworks. We are also dealing with non-JVM-based frameworks and dealing with it from the Raptor platform, using OSGi to understand the dependencies and figuring out what has to come together in order to serve that application, right? Last slide. We took from open source, okay? We take all these pieces from open source. We are looking at the problems of all these frameworks in open source, and we are actively contributing back to open source. On those fronts, you might not see an eBay label. You might see that the committer or the contributor of that code was eBay, right? There is also some other effort going on that we are talking about ebayopensource.org, which is saying any invention, any open source project that started from inside eBay, this is the outlet where we make our technology that we invented inside eBay available. So these are two separate ways. One is already existing project, we make use of them, we contribute our findings and our improvements back. The other one is we contribute new things. And we hope that you can also enjoy part of that in the community. All right? And with that, I'm just closing this. Yes, please.
How long did it take you guys to build the Raptor? How many people?
Raptor, well, how many people is very hard to tell. The Raptor core team was probably about 6-7 people only. But from the PDLC side, from the build side, from the developer experience side, altogether, I think it was at least about 30 to 40 people. Okay, yeah.
And then what's the journey? How long did it
We started this journey, formalized it in January of 2010, and our code went live in October, actually that year. Yeah, about 10 months to get the first piece of code live. And then another, yes, and then another 6 months or so to get the first application full scale. Right.
I'm not sure the last slide you are trying to say. Is it the Raptor will be the open source?
We are looking into that. Raptor itself, because Raptor is a meta framework, if you think about it, right? So it has this pluggability of eBay components. In order to make that open source, we have to make the component framework that goes underneath, the pipeline handler, everything that goes with it open source. We are looking at it. I cannot commit to it at this point. Okay. But parts, yes, exactly. And parts of it is coming out on here. All right? Yes, please.
So the slide that said the idea of production in less than 60 minutes, is that a vision or is that reality?
Actually, it's reality right now.
So do you have compliance or risk or legal requirements that could slow that down?
We do for certain applications, right?
So that may be an idealized case.
Actually, no. We for most applications, not every application needs compliance. Another part of eBay, PayPal, has got a lot more compliance, and they have to move slower. But if you are talking about pages that, like home page or view item page, that are non-critical in the sense that I'm not saying it can go down, could never go down, okay, because everybody looks at it. But in terms of compliance, there's no money you are paying on that. You just view the page, and then you jump to another application to pay for it, okay? That doesn't need compliance.
So there's a selection criteria.
Right, there's a selection criteria, and there's also a whole slew of automation that happens. So that there's SOX, if you are familiar with SOX, and we have our ticketing system, which is invoked automatically in this process. Okay, so a lot of the compliance pieces are already automated. That is applying to the whole of eBay. Anything that's specific to applications that deal with money, for instance, okay, that they have to do the compliance by themselves.
One more thing is like you want to just prototype it and try it out, like a beta. Right? So this is something which helps people to just go out and create an app in a couple of days. They can put it out and see what is the response, and based on that, they can see how can they go on. So we have something called eBay Gardens, where we put things which is like tried out by users, and if things are good, then it is productionized. So
I'll try.
It's like a faster prototyping and trying it out. Experimentation.
Do the betas have to go through compliance as
Yeah.
well?
It is.
I'm not sure how far you want me to go. But yes, I'll get to you. Yeah.
Can you talk about the strategy of how you're building this once and deploying them to different environments without having to swap any environment details?
Actually, the slides should be online. Sorry. Yeah. Mm-hmm.
So for that, basically, as Akara was mentioning, we have configurations, right? So you have configuration for different systems. So we have written a packaging mechanism where it packages code and configuration separately. And the configuration itself is basically for all the environments. So we have QA, production, pre-production, whatever environments, we'll have configuration in that. And the code is the same. We don't change the code for different environments. So when we build a deployable unit itself, it contains everything. So that means the deployment mechanism knows that, hey, you're deploying it to QA, so it will choose the QA configuration. When you deploy to production, it will choose production configuration.
I think you were there just before that. Yeah. No. All right, back there. Yes.
Which OSGi container?
The container itself is Equinox here, right? The server, the integrated server, we use a Geronimo 3, a pre-production or pre-release Geronimo 3 at this point, and we are moving to the released one. Back here, yes.
So besides the framework, do you provide other information public, like your methodologies, best practices?
Publishing those, we are still working on that, right?
Just a quick question. What kind of like environments do you have? Do you handle for DevOps? Do you handle your own servers, or do you use something like Amazon Web Services, or like do you have your own infrastructure?
For development, We use.
For everything.
Yeah, oh yes, it's all ours. Yes.